In this video, we're going to take a look at how to name and write formulas for binary covalent compounds, or you can also call them binary molecular compounds. So covalent compounds or molecular compounds are compounds that are made of two or more different elements, but this time it's only nonmetals. There's no metals in there, so simply nonmetals. So for example, H2O, that's a binary covalent or molecular compound. There's two different nonmetals, there's H and there's O. And the way these form is by sharing electrons. So instead of transferring electrons and making ions, what you'll see is usually these lines here. These lines are called bonds. And so what they show is, so these dots are electrons on the oxygen. These lines are connections, bonds, showing that the H and the O, the H and this O2, they're sharing their electrons to get a full valence shell in the end. So it's an electron share, not an electron transfer. That's important to understand. And it's only nonmetals. So there is a bit of a difference in naming molecular compounds, and we're going to see what that difference is. And one of the important skills you need to know to be able to name molecular compounds or covalent compounds is how to count atoms in a compound. So just like before, if there's no number, that means there's one. So there's one carbon in CO2, and then there's a 2 there, so there's 2 O's. That's a total of 3 atoms. So it is important to know how to count elements in a compound. And the reason for that is because when you name covalent compounds or molecular compounds, you have to use what's called Greek prefixes. The pre means before. So it's a small word you put before a word to change the meaning or to indicate something. So these are the Greek prefixes here. There's more than just 10 of them, but I expect you to know at least the first 10. So we have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, and they basically just mean numbers. Mono means 1, di means 2, tri means 3, tetra, penta, hexa like hexagon, hepta, octa like octagon, so on and so forth. And so you would never use these for ionic compounds. When you're naming ionic compounds, you do not use these. But when you're naming molecular compounds or covalent compounds, you would use Greek prefixes. So for example, let's say we had to name N2O. You'd first recognize that it's covalent because there's only nonmetals. And so you would first name the first element, which is nitrogen, and you would name the second element, O, by changing its ending to oxide, just like you would for ionic compounds. The difference now is that you'd have to use prefixes to indicate how many there are in the name. So nitrogen has 2. If you look in your prefix table above here, you'll see that di means 2. So we have dinitrogen. And then oxygen, there's 1, so we'd use the prefix mono. Now you wouldn't write monooxide, you'd write monoxide. So because there's two vowels, you would drop the vowel in the prefix there. So not monoxide or monooxide, monoxide. For example, if you had pentaoxide, you would say pentoxide, not pentaoxide. The only time you don't drop the vowel is if it's an I, like an iodide. But everything else you would drop. So our final name here is dinitrogen. Monoxide. That means you have 2 nitrogens, 1 oxygen. There is one more rule. We don't use mono if the first element is 1. So for example, in CO2, normally you'd think it's monocarbon dioxide, but no, because the first element is 1, we'd simply say carbon dioxide. That's the only exception there. You would use every other prefix every other time, just not when the first element is mono. You just leave the mono out, just carbon dioxide, for example. Again, these prefixes are not used for ionic compounds. Write that down somewhere, remember that somewhere. They're not used for ionic compounds. So, pause the video, try to name these 2 examples here, then unpause the video and see if you named it properly. First of all, you need to remember that these are covalent. You know that because there's only nonmetals in them. For the first one, we have 2 phosphorus, so we have diphosphorus. And then 5 oxygen, so that's pentoxide. Pentoxide. For the second one, we have PBr3. There's 1 phosphorus. We're not going to say monophosphorus, though, because we don't use mono for the first one. So we say phosphorus. And then there's 3 bromides. So we have bromide, bromine becomes bromide, but it's 3, so tribromide. You can try the following ones. I would recommend you pause the video, then unpause and see if you're on the right track. So in this situation here, hopefully you've unpaused the video at this point and you're just checking your work. You have sulfur hexafluoride, over here you have 2 nitrogens, 5 oxygens, so dinitrogen, pentoxide, PCl5, you don't use mono for the first one, so phosphorus, and then chloride, but it's 5, so pentachloride. NF3, don't use mono for the first one, so nitrogen, trifluoride. CS2, so don't use mono for the first one, carbon, 2 sulfurs, so disulfide. N3O6, trinitrogen, because there's 3, so tri. And then hexaoxide, but we say hexoxide, we drop the vowel. SO3, we don't use mono for the first one. There's only one there, so sulfur. There's 3 oxygens, so trioxide. Again, don't drop it if it's I. S4F10, so we have 4 sulfurs. Tetra, that's 4. Sulfur, name the first element without changing its ending. And then we have 10 fluoride, so decafluorine, but we change the ending of the second element to IDE. Okay, PS5. So we have phosphorus. Don't use mono for the first one. Then pentasulfide, because 5. Pentasulfide. And then now we have P4F8. So that's tetra, because there's 4. Tetraphosphorus, don't change the ending of the first one. And then 8 is octa, like octagon. Change the ending of the second one, so fluoride. Tetraphosphorus, octafluoride. So in this video, we learned how to name covalent or molecular compounds. They need Greek prefixes, whereas ionic compounds would not have Greek prefixes. In the next video, we're going to take a look at how to write formulas if you're given a name for covalent or molecular compounds.